I would like to welcome everyone who is here tonight and also the people online. I'm Nicola Di Cosmo, Luz Foundation Professor in East Asian Studies at the Institute. And it is a really great pleasure for me to introduce our speaker today, Andrea Rinaldo, who we managed to invite thanks to a generous support from the S.T. Lee Foundation to the School of Historical Studies. Andrea Rinaldo is professor of hydrology and water resources and director of the Laboratory of Eco-Hydrology at the École Polytechnique Fédérale Lausanne. He's also professor of hydraulic constructions at the University of Padua in Italy. And he's also president of the Istituto Veneto for Sciences, Letters, and Art. His career as a scientist has been marked by a long series of achievements. After he graduated from the University of Venice in 1978, he became, within a few years, a full professor, first at the University of Trento in Italy, and then at the University of Padua. But his international career took off right away. He has been invited as a visiting professor and research associate for multiple years at the Massachusetts Institute of Technology from 1993 to 2001. And he was also at Princeton University from 2004 to 2007. In 2008, he joined, as I mentioned before, the École Polytechnique Fédérale Lausanne. He has received many recognitions, many honors and awards, among which I would like to mention the Hydrological Sciences Awards from the American Geophysical Union and the Dalton Medal from the European Geosciences Union. He's a fellow of the United States National Academy of Sciences and also the American Academy of Arts and Sciences, as well as the Royal Swedish Academy of Sciences. And last but certainly not least, the Italian Accademia Nazionale dei Lincei. Last year, he was the recipient of the Stockholm Water Prize, which is known as the Nobel Prize for Water and Hydrology. Of his 330 peer-reviewed published papers, 53 appeared in prestigious journals such as Nature, Science, and the Proceedings of the National Academy of Sciences. His work is extremely broad-ranging, including theoretical and laboratory work in the general field of water controls on living organisms. But he also has done extensive field work in places like Burkina Faso, Bangladesh, and Haiti. His research results show not just how river networks and water basins work from a hydrological perspective, but how water distribution impacts ecological processes and biodiversity. We will learn more about Rinaldo's research in a minute. Before we do that, let me add just a personal note. I met Andrea in Venice, Italy, where we began to talk about a topic of common interest, namely climate. Anthropogenic climate change today represents a global challenge and one towards which I think it is impossible to remain indifferent. But I would submit that the most critical challenge in research today is not so much finding solutions to big existential questions, but to combine different knowledge systems so that we can find solutions to big existential questions. The work by Andrea and other environmental scientists made me a lot more aware of the complexity of ecosystems without which life, social and biological, simply cannot exist. Indeed, Andrea's work is a paragon of scientific rigor and human sensitivity, very much at the cutting edge of a type of research that tries to build better syntheses between natural and human systems. But I would be remiss if I did not mention one last but critically important detail about Andrea's work and life. Of the 4 books he has authored or co-authored, one, which he wrote in Italian, is titled about rugby, towards an ecology of the oval ball. This is a wonderful homage to a sport Andrea loves and practiced at a very high level, both in the Italian Premier League and on the Italian national team. He continues in various capacities to this day to support the development of rugby as a sport in Italy and internationally. So with that, please welcome Andrea Rinaldo.
So much, Nicola, for this wonderful introduction, and particularly its end, of course, means a lot to me. And well, I have to tell you that I came to admire very much what the new wave of historians are doing in combining, in fact, the kind of things that come from the say geophysical research or hydrologic research that informs, in fact, the history of history, and about which I'll be talking about. But let me start by saying that it's a great pleasure to be here, and I've never been associated with the Institute, but I have a connection, which I'd love to mention because it's occasionally talking about a person who's not here any longer, very dear to many of us. And the sense is great or small our discoveries talk about a journey in which we embarked where the outcome of our searching was very unclear, and accompanied by the institution and colleagues. And in particular, one colleague in one state of mind that was generated in this area in Princeton is due to Ignacio Rodriguez Iturbe, master of contemporary thought, late institute professor at Princeton, with whom we've collaborated for something like 40 years, and many here I know him well, knew him well, and so on. But for us, the spirit of the place, when we got stuck working downtown Princeton and we needed some inspiration, what did we do? We came here and walked around the pond, because Ignacio used to say that walking around the pond in the peripatetic mood that is meiotic, like prompting out learning and understanding, was done here. So I'm tied to this place. So let me begin. Of course, it's for a scientist. The effort is just to try to give you a relatively reasonably complete idea of a theoretical background that is behind what we do, with some implications on the matters of interest to historians. So it's indeed a challenge, fascinating challenge, in fact. And the first picture that I would like to show you is I took it on the banks of the Meghna River, which is a tributary to the gigantic Ganges-Brahmaputra, in fact, deltaic system in Bangladesh. And it's particularly, in my view, interesting because it exposes one key point that drove much of our research, that is the weakness of our predictions of even simple events when it comes to environmental, to ecosystem services and process. For instance, even this this weakness was a liability in our ability to put a price tag of ecosystem services. And that's something which we relate to contemporary environmental economics, and something which I'll touch upon later on. But the picture is simply taken. This young fellow was claiming that the sacred waters, the mighty waters of the Meghna, couldn't cause anything, any bad thing, etc. In this case, the ecosystem service we're talking about is simply drinkable water. Now, if you consider that this happened like a couple of 100 meters downstream of the largest Dareel hospital in Bangladesh, where in fact cholera, for instance, in evolutionary sense, irradiated from that point worldwide. And if you consider that a few minutes before I had visited the hospital, because much of my work concerns waterborne disease prediction and evolution. Then at that point, 200 meters upstream, I visited the hospital, and there were something like 70 persons seriously diagnosed with running cholera. And the fact that we not even respond reliably to such a simple question, will the young guy catch cholera? No, you catch cholera if you ingest a sizable number of bacteria, of Vibrio cholerae, of the pathogens, in fact, means that you have to be able to predict point-wise in a specific moment of time the concentration of something which happens in an unknown condition of leakage from the hospital, and unknown condition of survivability of the pathogen. And this liability haunts us up to now. And it's something which we need to take into account. But is there any hope of doing any better? Well, this fits in the context of the rapidly changing world, something which Nicola mentioned. And what happens, it's why are we talking about a rapidly changing world, and why should we change according to it? What you're seeing here, and I want you to, but to keep this, I became aware of this way of introducing the subject at the Crutzen lecture that Professor Stalker gave like a year ago in Poland. And what you have to retain out of that is the general patterns of this. This is called the hockey stick diagrams. And there's a really compelling number of socio-economic indicators of, as you see in the next slide, of turbation of biosphere, biogeochemical indicators. In which what you observe is that since we started measuring, like early 18th century, more or less, technically, in fact, the longest time series, regular time series of daily precipitation was established in 1710 in the city of Padua, in fact. Abate Polleni started it. And what you observe is why it stuck the popular definition of hockey stick diagram is the idea that essentially through 3 centuries, you've been going through a quiet Holocene in which very little was changing. All of a sudden, to start booming up without control, almost exponentially, the hockey stick diagram that you're seeing there is not a matter of a particular units which you're choosing. It's extended to a number of quantity. You're talking about population, for instance. You're talking about gross domestic product. You've been talking about foreign direct investment, as you've seen here, urban population. Of course, water and energy use are a measure of that. What the causes remains to be seen. But what is absolutely unheard of is the rapidity of the changes. Certainly, as and these are the biogeochemical indicators, but you have quite a few of them, in fact, and from the concentration of greenhouse gases like CO2 or methane, which is 20 times more dangerous, in fact, which comes into the fore because of with increasing temperatures, the melting of the permafrost means a huge injections into the atmosphere of a greenhouse gas of that thing. But whatever you have, any measure, and I won't enumerate all of them, what I would like you to retain is this idea that something started happening around the 50s of the 20th century, and then the acceleration started growing up. And that is troublesome in a sense, because in a sense it's welfare increasing at the origin of that, and with the things that we have to take into account. So don't buy the obvious observation that what Naomi Oreskes has called the merchants of doubts are telling you. Of course, cycles have always been. There always been cycle. We have the scientific proof that in deep time, we've had periods in which the temperature was much higher, the temperature of the planet, the fever of the planet, as was called, in fact, is in the reduction to one factor is the most important single problem that we have to face. Certainly, we've had periods with much higher atmospheric temperatures, but the changes required 1 million years, not 100 years. It's the pace of change, in fact, what we have to keep in mind. And the pace of change is what is forcing us to speak up. And that means I'm a hydrologist and I'm interested in ecology. So what are we interested essentially in? What is hydrology all about? It's about floods, it's about droughts, it's about the fair distribution of water, and all cascading into that, all the social and economic processes that come along with that. And I will pitch for the importance of those in fact, factors in the history of history, in meta history, if you want. And what you're seeing here, it's a recent flood. It happened in a river Idice in northern Italy. It's a medium-sized river. Well, but what is important about that, there are two features that characterize it. The breach of a levee has been significant, in fact. And the first thing which is significant is that it came after 1.5 years of very serious drought. 2 weeks after the official pronouncement of the ending of the drought, you had events characterized by a phenomenal intensity. And the second thing that you see is the effect of the Anthropocene. What you're seeing here is that when you have a breach, the river abandoned totally the riverbed, completely, 100%. telling you that whatever the Anthropocene has done has made it completely unsustainable. Because it's not that something like a breach was a part of that, but part remains in very rough. It abandoned it completely. And of course, in 2022 in Pakistan, it was a major turbation of another factor. In Pakistan, you had during the monsoon a flood that covered half of the country, in fact, which is unheard of a precipitation which we have seen before. And you seek certain simple explanations, and I'm delighted to offer one. In the reduction to one factor, remember that a physical law, which is inescapable in a sense, is the Clapeyron's law. It says for every degree centigrade of increase of temperature of the atmosphere, the water content, water vapor content that atmosphere can hold varies from 6 to 8%. So it's a strongly nonlinear phenomenon. So there's a hell of a lot with the warmer atmosphere. There is a lot of water that hangs in there. And if it faces a cold front, you get stronger rains, erratic patterns, and inherent variability that you have in the system. And here, this also, the rapidity with which we actually have to deal with the changes that you observe in the environment has consequences. For instance, one is that typically for instance, the laws and any kind of criteria for defending against the destructive water, against the floods, would be to respect a certain freeboard with a certain return period flood. You probably heard the name in here. Return period is not the deadline for the recurrence of an event. It's simply, in probability terms, it states the average inter-arrival between events that have a certain value or bigger than that. What is interesting is that now, and in Princeton, you do have specialists, in fact, in the so-called meta-statistics, something in which you take into account the fact that you're drawing from a distribution which is rapidly changing, so you cannot really rely on the past, not entirely on the past, to have an idea of the frequency with which certain defining event will occur. And in this case, we call meta-statistics or statistical statistics, because the parameter of the distributions, of the extreme value distributions, in fact, are considered as random variables itself. And these distributions allow you to study with certain precautions, and I won't go into detail, but something in which even on relatively long time series, like the ones we have in ERA, this was a courtesy of Marco Marani from University of Padua and then Duke University before, you have the obvious observation that extreme events tend to become bigger and bigger and bigger. And it means that even the criteria with which we define the flood limits cannot hold anymore. So the fact is we cannot simply hide our head or turn the head on the other side. The idea is that the fact that the hydraulic protection of the territory and the idea that these events will become more and more common, more and more frequent, in fact, is something we have to deal with. And what is interesting is also the statement, the future is not what it used to be. It's very interesting small research that you can actually do. And you find that if you look in the US, in fact, it is a Hall of Famer from New Jersey, the baseball Hall of Famer, Yogi Berra, whose name was, I think, I don't remember what, Yogi was, we said so the future ain't what it used to be. But in reality, the proper citation goes back to Paul Vidal, a philosopher of a French philosopher that wrote in 1937. It is unlikely that there is a connection between two citations. But certainly they synthesize very powerfully what we're talking about, something in which the future is not what it used to be. In fact, and we have to take that into account. And then talking about another defining factor is, of course, we're talking about the droughts. Governing waters means, and discussing the social and economic implication of that, it's obviously, it relies on droughts are very important. What you're seeing here is the colors veering towards the red are the meteorological anomaly, the meteorological drought. That is the anomaly with respect to the average consolidated in a large amount of time in terms of precipitation, simply rainfall quantities, in a period in Italy which lasted which was about, it started in January 2022 and ended in April 2023. So it was a significant one. So what you see here in this particular snapshot, that plenty of red means you are way below average in a place. But you also see that in southern Italy, you'll be very happy at that moment. So it's the heterogeneity of the patterns that you have in space and time, the feature, the marks, in fact, the erratic characters of a response on how you, in fact, these higher temperatures of the atmosphere generate hydrologic patterns. It's something which we have to take into account. And of course, once we talk about droughts, we have different droughts, and the cascading of droughts is something which is quite interesting, because it depends, for instance, if you look at the soil moisture drought, for instance, which comes later and damped in certain respect, it's fundamental to understand, again, factors find you that half of the population of the world subsists of rain-fed agriculture, so something which we need to take into account very seriously. Or talking about the three pillars, we're talking about floods, we're talking about droughts, and about a fair distribution of water, which is fair distribution of water is a very important part, because you may have technically enough water, but you may be very unjust in the way you distribute. Distributed justice is something on which I shall return quite a bit, because figure, for instance, in my country, I am Italian, in fact, the average water consumption per day is almost 300 liters per person per inhabitant per day. Liters per day per inhabitant, 286 in particular. And if you look at for instance, in sub-Saharan Africa, the dotation of what a woman can carry on her, in fact, head, one of those big buckets that they use walking, like you can see in this case, to filthy phreatic aquifers that you have in places like this. And that's the norm, even for a distribution of labor, which is typical of those countries. So the idea is that gradients of welfare are also engine for migration, something which is part of the equation, in my view. And this picture brings us to the city where I was born and raised, the city of Venice, which is also part of the general idea we have about governing the waters. What you're seeing here is a subtle thing, because it brings us back to the suspended moments of the lockdowns during the pandemic. If you look carefully, you see that, in fact, the photographer quite smartly has capsized the pictures. It's upside down, actually. The reflection is taken as the real part, and that exposes the complete immobility during the day of the waters of the Grand Canal at the time. And why this is significant? Because even we thought that we would be spared wars, we would be spared famine, we would be spared pandemics. So we got all of them, in fact, in the last few years. And what is interesting about this, and this is the connotation again, because in the past, historic, in fact, epidemics that became pandemics. If you think that, for instance, the Black Plague of the 15th or the 16th century, in fact, took the grinding of something like 20 to 30 years to become pandemics. In this case, it took one flight from Wuhan to Toronto to have a thing becoming pandemic. It's the rapidity, the key word. And the rapidity is also the one with which, in fact, nature regains its properties. You think that in my hometown, I think you started seeing dolphins, in fact, in the lagoon, octopuses appearing in a matter of 2 or 3 days. So nature regains very, very rapidly, in fact, its proper. And why this is relevant, the general issue? Because, in fact, looking forward, we have to think that, okay, again, climate is changing rapidly, and so should we. What is the message that comes from the city of Venice? When we saw the latest release of the IPCC report, the regional studies on the Northern Adriatic, it became clear that, governing the waters in the city of Venice is not going to be easy, because what you've seen here, you get the year on the horizontal axis, and then the mean sea level, as you see it, measured in black, what you have seen up to today, essentially, and the projections done by these techniques that the Intergovernmental Panel on Climate Change is using, that is ensemble averaging of several computational tools, reasonably reliable, in fact. And refer to models don't do predictions, models do scenarios, and the scenarios are related to the so-called ARP, the reference concentration scenario of of concentration of greenhouse gases, or CO2, in fact, in the atmosphere. So essentially, whether or not we'll be back to a system in which, depending on the type of increase of the temperature that you have, you're going to have a certain response. And what happens is what is supposed to be by the IPCC, in fact, is the most likely scenario, is simply, in fact, the one in which business as usual, that is the growth in the temperature we're going to be seeing the next century, the next 100 years, will be at the same pace that we have today. And it's considered an optimistic scenario, in fact, because it means that, and that goes back to the complicated questions, mitigations versus adaptation. And I return to that, however, quickly, because what happens, mitigation means going to the root cause of a system and being capable, in fact, and if you talk to the dur and pure of the scientist, we say, no, it has to be only adaptation, because if you go to the root cause, you solve a problem with mitigation. With adaptation, don't solve anything. In reality, what happens is that I'm strongly pessimistic about the idea that, having worked, especially in the south of the world, for quite a bit, in fact, the capability that will have the authority of telling the whole world that, in reality, certain hard-gained privileges and that are the consequences of a well-being could be let in the name of some common interest. I think it's been complicated. What happens is, means in this case, what it tells from the specific case of my hometown, is that within 100 years, you're going to have a meter more of sea level rise. A meter more of sea level rise means a lot of things. That in reality, a meter more, because it's like 80 centimeters of relative sea level, plus the subsidence of a platform over which sits the entire geologic structure over which the city sits. Maybe just biased my judgment, but in reality, I think that preserving Venice for future generations is something which will be more than a duty, I believe. It is something in which we'll have to seriously advertise for the fact that with a meter more, the city will simply rot away. That the MOSE, the system that interrupts, that was built recently, it took 60 years for us to being able to construct a system which really we took Italians 60 years to generate these blockades, which was something which essentially had no alternative. And in reality, we don't have 60 years to wait for thinking what to do with a chronic problem in which you will have to have the MOSE closed 260 times a year. So you won't have any lagoon. You're going to be a filthy pond. You're going to have, you're not going to have a city, because the city will be rotting away because the cycles of capillary rise of seawater and recrystallization of things will simply have a system rotting away. And the houses and the work of art that has seen has been the marvel of the world will be gone in about 100 years. This is another case. Okay. Let me. Oops. Sorry. No, that was it. And you're supposed to start, but it doesn't. It did earlier. Let's go like that. Maybe now it will start. Here it is. And is the end of the bad news? No, because in fact, there exist uncertainties and events that have not probability zero. Is like the complete melting of a Greenland ice. You see what's seen here. These are data, recorded data. And the same thing happens if you look at the Antarctic sea ice, the extent of the Antarctic sea ice in this first Nino year that you see now. The effect is dramatic in the sense that if you overcome certain tipping points that will generate the complete destruction of which was seen in earlier times, of course, and you're going to have a complete melting of that quantity. You're not talking about a meter of sea level rise, you're talking about 7 meters of sea level rise by the end of the century. So long story short, the idea of governing the waters has different facets, and they all bring into the system that you have in there. So one digression that this image brings us to sub-Saharan Africa, which, as Nicola was saying, I've been working for years until it became impossible, because the permeability of the frontier with Mali, with all the guys that fled post-Gaddafi Libya, armed like you won't believe, started roaming through the continent down there, and it made it impossible to continue long attended work on debilitating disease in particular area. And what is interesting, in fact, in this case, is, well, the first point I want to make is that I think that it's easy to convince you that water sits firmly at the center of the history of history, in fact. And you could quote, for instance, poets, if you want, easily enough. Poetry catches the essence, in fact, very happily. Winston Hugh Auden, is a marvelous poet, in fact, says that 1,000 have lived without love, not one without water. It's significant for archaeologists as well, in fact, for historians as well. But there's one thing that is interesting, also in view of tomorrow's debate, in fact, which I'm looking forward very much. And it goes into a particular historian, Bertrand Russell, in 1934, had his own definition, which pleases me, but it requires some corrections, I think. And he said that history can be viewed in many ways, and many general formulae can be invented, which cover enough of the ground to seem adequate if the facts are carefully chosen. So you cherry pick facts, in fact, to fit the model of history, etc. But I suggest, without undue solemnity, the following alternative theory of a causation of the Industrial Revolution. In fact, what Bertrand Russell was doing was up to the throat of a historic materialism in his chapter on the history of Western philosophy. In fact, he was talking about Karl Marx. And what he was saying is that the causation of Industrial Revolution. And he says that industrialism is due to modern science. Modern science is due to Galileo. Galileo is due to Copernicus. Copernicus is due to the Renaissance. The Renaissance is due to the fall of Constantinople. The fall of Constantinople is due to the migration of the Turks. The migration of the Turks is due to the desiccation of Central Asia. Therefore, the fundamental study in searching for historical causes is hydrography. Now, so that pleases me, but it's not entirely true. What we know exactly from all the modern day science is that there are multiple factors that act into the system. But the idea that, in any case, certainly I would be content if you accept that water would be part of the equation. I believe very much that it is. So I messed up, of course, all the orders of my slides, but I'm still fantastic how we could. I don't know what I did, so I'll go and content. But so without the kind of questions, now I'm entering into the things that was the work which I was passionate about, and there was the last 20 years or 30 years, if you want, of my work, and very much part of the work I did with Ignacio Rodriguez, about which I'll be talking in a minute. The kind of questions that now become important is that, okay, ecosystem services, can we give a price, put a price tag on the ecosystem services? Do we have a compelling way of characterizing them? Will large scale water resources management plans consider the biodiversity reduction that would include the protection of the biodiversity? Can we look into the shape, for instance, of a river network as a template for how disease propagates? Will we be able to prevent a water development scheme in the face of, for instance, immaterial values, like, for instance, the extent of disease that the irrigation networks that are associated with those development schemes will bring into debilitating disease and poverty reinforcing diseases? And are biological invasions, including the Neolithic transitions that more or less shaped societies as we are, be somewhat written in the form and the function of river networks? Because these are the kind of questions that we've been addressing for a long time. And let me get, I see one of the authors is here, Simon Levine. One very important, in fact, issue in here has to do with environmental economics. So the general issue is that in the past we didn't have much appreciation for the fact that the weakness I was talking to you about the weakness in our capability to put a price tag on ecosystem services stems from the fact that it's a relatively recent acquisition is precisely related to the fact that if you want to put a price tag in economic indicators that ignore the value of a natural capital are misleading at best in characterizing, in fact, the wealth and the poverty of nations. And there was the work that it's particularly, come on, it's unbelievable how I completely altered my slide. But anyways, so economies can thrive only for a time by mining the natural capital that we have been seeing, say by decimating forests, by damaging soils, by destroying the key ecosystem service, by depleting or destroying, in fact, non-renewable resources, or slashing biodiversity that you have seen in there. And if environmental thinking, which is and against development thinking, and development thinking, as was written famously, is stacked against nature, in fact, the key point is that environmental thinking will have to hang on and become quantitative. And I shall propose here a few examples, in fact, which I'll be talking about. But in particular, the work of Simon Levine and Partha Dasgupta, the recent one, is very important in that view, because it says that economic factors that underline biodiversity loss are a new frontier of economics in particular, because contemporary economic thinking does not acknowledge a very important fact, the fact that human economy is embedded in nature. And Simon will correct me if I'm misrepresenting his thoughts. But the idea that it treats humankind as a customer that simply draws on nature. And what they have proposed is very important in my view. It's fundamental work. They propose a grammar for economic reasoning that's built on that specific error, in fact. And that's what now the frontier of economics is, in my view. And in reality, in some manner, we are under the spell of so-called Kuznets curves. Kuznets was an economist expatriate from the Nazi Germany, in fact, and he became a professor at Harvard later on. And he studied the recovery after the Second World War. And the Kuznets curves, true or interpreted curves, are something like, which I kind of represented in this case, is something in which if you parameterize, in a sense, income per capita, richness, if you want, individual richness, against inequalities, that will become these curves which are concave down. Meaning, after an initial phase in which you would have that the bigger richness means more inequalities, will be followed by a phase in which those inequalities will be reduced. So this motivated, in fact, development thinking in the sense, okay, let's get richer and things will become perfectly okay. Now, enter Thomas Piketty in this super boring book, whose 30 pages are very exciting, however, in the capital of the 21st century, bothered to check the facts. And he found out that he was absolutely correct what Kuznets had done, but it was precisely because he was talking about society that were recovering after a major perturbation, like a war, like it will be today after the pandemic, or after the famine that now is touching the MENA countries, in fact. In reality, if you do that, and you see that today, what you observe at the increasing of richness, inequalities tend to increase without bound. And in fact, if you look at empirical data, I had an instructive discussion with one of the professors of the Institute yesterday about what is a power law, essentially. What is a straight in a log-log plot? It's an interesting thought. It's interesting talk that at time occupied sizable parts of theoretical physics conferences. But if you look, for instance, of the distribution, probability distribution of net worth in US dollars, it's reasonably well described by a power law. Power law is something which looks straight on a log-log plot. It's essentially in the form of I won't talk in any detail in that. But if that is the case, if that is a reasonable model, that can be solved exactly in this case. And if you look at the fractional wealth against the fraction of the population that holds it, that can be solved exactly as an exercise you do with undergraduate students, in fact, in our classes. And what you find out that the empirical coefficient that you have observed in a number of cases, it will be interesting to find out, for instance, why the slope of that is the same in Bangladesh and in Germany and the United States, but there's something else which deals with a feature which I will be touching upon very briefly, the self-organized characters. Why should phenomena that are generated in completely different contexts get to the same result? And the result will be the slope. The slope is the essence of the system. But long story short, with the exponent that you have, with the richness that you have in the US, the exponent is 2.1, and 2.1 is the value that you see in here. The value that you see in here, 0.2. And it means that 80% of the wealth is inevitably in the hand of a 20% of the richest fraction of the population. That's the tendency that you see inevitably in the system. So this is to talk about inequalities. So it's not true that development thinking cannot be simply as simple as that. And let me get to a true master of contemporary thought, whose memory I cherish, and Ignacio Rodriguez Iturbe, in fact, was at the center of a process in which he brought river networks very much into this system. Why? Because for the first time, at the beginning of the I would say early 80s, you start to realize that you could objectively, you could actually remotely acquire and objectively manipulate information taken remotely about the shape of rivers, the dendritic structures generated by erosion patterns. And they have a phenomenal character. They are universal, regardless of the initial conditions, regardless of the geologic substrate, regardless of the vegetation that you have in the system, regardless of the climate. You can, if you take out of a map of a river the scale, you cannot even tell whether it's a small or it's a big river. And that is important because that, compared with the literature that was appearing then, it was the literature about what was behind the dynamics behind the geometry of nature. It was an important factor. And in fact, very hardly you could find, in fact, in the scientific literature, data as rich and verifiable as the data that concerns like clean six orders of magnitude in evaluating river forms in which the dominant process has been the same. And that's what the greatness of the system. So you have pictures like this. So what we had at that time in understanding a certain sector, a certain narrow perspective, but broad enough for a number of reasons, of how nature works, in fact. So pictures like these are not pictures. These are not a photograph. This is a digital terrain map, color-coded, to make it look like a real one. And in reality, what happens is something which reminds what you have seen about the wealth. So something in which these power laws, this idea, this the mathematics that describe these systems is really universal. And it started allowing us to taking a look of something which is, I won't go into the details, but the idea that if you study the distribution of aggregated area, for instance, if you close your eyes in a map, suppose you have like a spanning network that covers it all, generated by any kind of algorithm that you want, or any kind of observation that you want. At any point, you can characterize the total contributing area at the point, which is the master variable for defining the river network. That distribution is universal, and on which I shall not build. But the idea is that nature tends to have a reproducibility, which is the way through which we can characterize form in the case of a river network in this case. And that connects to two giants of contemporary thought. And one is Benoit Mandelbrot, largely underestimated by mathematicians, because, by the way, largely because he was an engineer by training. But without him, we wouldn't be talking about what you have seen. The idea is that mountains are no cones. Clouds are not spheres. Coastlines are not simple broken line, nor does lightning travel in straight lines. The fractal geometry of nature was identified. It was a way in which even the very fact that Mandelbrot, without inventing any of the mathematical tools, showed it to us by computer graphics, changed the ball game completely. Nature has the geometry of nature has a particular mathematical language that describes it, that shows how nature, in fact, applies. And the second one is Per Bach, that wrote the modestly titled book, How Nature Works, in fact, but it's the father of so-called self-organized criticality, something in which it sounds like this: open dissipative systems with a gigantic number of degrees of freedom, rather than doing in every single outcome of its realization something different. We do always the same thing, regardless of any kind of perturbation that the system would have. And this is called self-organized criticality. It's the base for repeatability, in fact, of form that you see in nature. And then there's something which now starting approaching the idea of ecosystem services. Another important ingredient is due to Stephen Hubbell, in fact, the neutral theory of biodiversity. In some quarters underestimated, and yet a very powerful tool for unlocking certain secrets of nature. And Let me show you an exercise which was in which Simon Levine was involved. Ignacio was what the leading author, and some of our students were involved in that, which is, in my view, still revealing. It's an exercise where we show you some simple things. Suppose that you have like a system in which you have to decide what is called in ecology the substrate for ecological interactions. Meaning you are at the point, I'm a species, I can interact with my nearest neighbors, okay? Let's suppose for now that the range of my interaction is only my nearest neighbors, okay? It could be something bigger, you call it in ecology, the kernel of the interactions, or it could be a mean field, something in which you can interact with any other place in the system that you have. Just figure in mind only what you're seeing here. In the two cases, the differences that you have in here, in one case, the difference is only who is your nearest neighbor. In some cases, you have only directional dispersal because you have only connections. For instance, this guy here is connected to this guy, but it's not connected to that guy. So two places, two sides in which you may have ecological interactions, maybe they look quite near to each other, but it could be related to a very long path. So this is embedded in the fact that gravity drives water to move. And then in this case, what you have is that drainage directions are generated by the substrate for interaction, which is the terrain over which these networks are generated. In the second case, and I pay due tribute, they call von Neumann neighborhood. In fact, professor, one of the greatest minds of the last century, was a professor at the Institute of Advanced Studies. The von Neumann neighborhood is so-called, well, is that much better than that anyways, but in this case, would be like the nearest neighbors are specified exactly in this case. So my neighbors are my nearest neighbors or something like that, but for focusing our mind is that on this and what you have. And that's one of the connectivity that we have. So keep in mind that these are the two differences that we inject into the system. And what we do here, it would be an exercise that started in a political science. It's called the voter model. And the voter model says that you have a distribution of opinions at a certain point, and like the colors that you see in this diagram that you see in there, and the system proceeds as simple as that. So you randomly check one point and you cancel the political opinion, the color. And you have two options. In one case, you assume simply the color of the most numerous colors of the same type that you have in your neighborhood, however defined. And that's interesting because it's neutral in the Hubble sense, because what you have in here is that there's no political opinion that prevails over the others. There's not one guy which is less numerous that wins over the other. It's neutral in the sense, it's only the number that counts. One makes for one. But what is interesting about this is that in this case, what you have that if you do that without any other modification, what you have in the system is very interesting, because in the end, you're going to have, you let it go, you let it run, and in the end, you're going to have only one political opinion, only one color. Why? Because in the end, the asymptotic limit is known exactly, and will be the color or the opinion, which was the most numerous at the beginning. So it's completely dominated by the initial condition, so worthless. The variant that was introduced in this case is called the diversification ratio. That is, from now and then, they say every 10 to the minus 5 with a certain probability, like 10 to the minus 5 or whatever. Rarely, what you do, you kill a particular opinion, a particular color, and you substitute with the color which is not there any longer. It's like what is called diversification ratio in ecology. It's something in which you generate a new political idea, a new something which starts the process. And what you're seeing here is the following. The only difference between the two is simply the nature of the substrate. That is, in one case, it's directional dispersal. And in the directional dispersal, what you see in the system here, in the savanna-like system in which you interact with all the others, you're kind of exposed to all kinds of perturbations. In the second case, you have a network process. And what this is telling you, it's a completely abstract example based on the neutral assumption, and these patterns seems to be like an exercise. Now, what happens is that take it to the lab. That's what we did. In fact, that was done in my lab at EPFL. So you do that and you run the example. I'm not making a long story short, but I'm telling you the roots of the fact why, in fact, our predictions on how biodiversity, how biological invasions, and how waterborne disease, where the substrate for interactions is the river network, which is not the entire set of substrates in which you might have it, but certainly is an important one. It's a small segment of understanding of how nature works. In fact, in this case, what you do an exercise in which you simply do, mechanically an operation in which you put, like, for instance, 21 species of protists, and you start doing the dispersal yourself. In one case, directional, in the other case, in von Neumann neighborhood. And what is remarkable, there's nothing neutral in the system. There are bugs, living bugs, actually. It's a system which you think it's done, it's properly done with proper replicas, with proper care for making sure this is not an artifact of the way we manipulated that. And the results you see in here. The essential result is that neutral pattern doesn't imply neutral process. So the neutral pattern is what emerges. There's something bigger about it, which is embedded in the form that you have in there, that is oozing out into the function, in this case, is ecological corridors. And then, and I'm accelerating towards the end in this case, what you have in there. Then from the infinitely small, that is replicas of plates of this kind with like 90 wells or something, to the Mississippi River Basin. There was in Simon's involved in that, but it was the idea of Ignacio Rodriguez, of course. And in this case, you look at the Mississippi River Basin, which you took as a data sets, for instance, a very accurate, in fact, survey of a fish that you have in that system, a very fish species that are measured in abundance and in different types. And what you see in here, you see that in the end, certain patterns emerge. What you see in here, LSR, the label of the upper graph, it means local species richness that you have. That is essentially how many species you have in different places. And what you see in there is find this curious thing, AARP, is annual average runoff production, how much water passes through the system. And this can be measured very precisely. In fact, we have very accurate measures. And back to the fundamental causative factor of history being hydrography, what you see in here is that even in this case, it's written in the form, in fact, the shape of a local species diversity that you have in Mississippi River, down to a detail in which in reality you can actually work out, and that happened in this case, a very detailed model of how, in fact, species, the biodiversity it unfolds along the axis of a river, which is a fairly interesting point. And then let's go to other giants of last century. Fisher, Kolmogorov effect, something which Simon has worked, has gave fundamental contributions to, biological invasion, something in which I have a system in which essentially, if you have a system in which you do have actually diffusion of particles which reproduce, and you have a certain curve for the growth, like a logistic growth of any kind of living organism, which generates, it reproduces in a process which is typically suited to large time scales, to comparable time scales, they may in fact generate these solitons, that is, waves in which the speed of propagation is particularly, it becomes constant, like in this case. And it depends on the rate of, on certain parameters, which I won't speak, but certainly the mathematical tools are very, very interesting. And by the way, that reminds me that the famous paper by an archaeologist, Albert Hammerman, and Cavalli Sforza, in fact, the Neolithic Transitions, a beautiful book which has been recently published in the classics of Princeton University Press, in fact, showed for the first time how to interpret human migrations according to occasions of this kind. And in fact, recently, and there's been a very interesting results carried out by some Spanish physicists, in fact, they realized that if you look at certain data sets, like the rush to the west of the America, in fact, the rush to California, in fact, was in fact, could be interpreted in a way which is according to these models. It's a model of diffusion with reproduction, with a certain carrying capacity generated by the system. And what is interesting, in fact, it shows us without any doubt that if you take an isotropic diffusion, like in that case, it would be simply overestimate the speed of propagation of a wave of migrations to the west, in fact. The only real values are if you assume that the colonizers would follow rivers, fractals, one of those particular species that you have in there. But again, like in this case, what you have is that something which, again, back to the Mississippi-Missouri river system, we can actually look at what happened with so-called zebra mussel. The zebra mussel is a fantastic competitor, which was brought in by some Ukrainian cargo ship, which downloaded illegally, of course, the ballast water too close to the Chicago Canal, and some veligers, that is the larvae, in fact, of this, were injected into the Mississippi-Missouri river system and started blossoming in that system. They generated one of those waves, which is also interesting for understanding, again, other things on how nature works. For instance, in this case, you would see that the zebra mussel were generating a very well predictable, according to a model of diffusion and a logistic growth with certain stages or intertouches, etc. But all of a sudden, we see that this goes down the early part of the Mississippi River, and all of a sudden, you get that 1,000 kilometers away in Idaho, in some place, you get puff, all of a sudden, this totally non-native, in fact, species becoming a formidable competitor, started colonizing it. What happened was, again, what we call now in modern jargon, multiplex networks, because what you have is that use for recreation, use boats, you bring them in the place of the Mississippi River, you don't clean it properly, the ballast water, you put it on the car, you bring it 1,000 kilometers away and you put it in the water. And that's how you restart, in fact, biological invasions. But in a sense in which whatever happens can be very well calculated. And this for the infinitely big, and this for the infinitely small. So we can reproduce that in a protistodrome, something of this kind that you have, some which is this size, in which you have in the laboratory, something of the kind. And we had different types with this E. coli in this case, how they diffuse and reproduce. And we have a feeling that once we measure the parameters of the two key parameters, as Kolmogorov and Fischer pointed out, like the reproduction rate and the diffusion coefficient, you predict exactly the speed of the front, like Cavalli Sforza and the archaeologist Albert Hammerman has done. And these are the kind of pictures that I'm fascinated by, this Pollock-like structure, which is generated in a stupid laboratory of this size, which was done in our place. The last thing that I'll be getting in touch about, so we talk about fair distribution of water means a fair access to resources, as we said, in some cases. And in this case, the step was done relatively later on. This is how, in fact, this universality of form transfers to the universality of behavior, into the robustness of evaluation of the systems of rivers as ecological corridors for species, to biodiversity interaction, for populations, for biological invasions, for pathogens of waterborne disease, which is also relevant to the conversation that we're trying to have about equality. So essentially, what you have in a tree of this kind, you can see, in fact, that every node could be a community in which you have, like, physical community, in which the demography of a disease can develop. It's easy to realize that in reality, in a system of this kind, you can characterize particular diseases. In this case, for instance, we're talking about cholera. And at that time, in 2010, the major outbreak in Haiti operated. And that's why we established our base for as long as it was possible. It wouldn't be possible today if you heard the news about what's happening in the island, totally in the hands of a few gangs. There's no state. Even in the case, what happened in 2010, Haiti had been hit by a monstrous, is one of the most active tectonic places in the world, by a major earthquake that killed 300,000 people, destroyed whatever infrastructure was in there, whatever, but no streets, there's no water supply, there's no water distribution system, there's no police, there's nothing in the city in there. And that's where we brought in the system, because that's more or less what you have in the system in there. And what is interesting about these are the market of Carrefour, which used to be a thriving market not very long ago. If you think that Hillary and Bill Clinton had a honeymoon in Carrefour, so it wasn't a million years ago, in fact. You see a bunch of crooks in sequence, how fast, in fact, their rapidity can destroy. And this is the poorest country in the world. And the country had been cholera-free for 200 years. So it's reasonable to assume the population was completely naive, that is naive in epidemiological terms, that is susceptible to the disease, because the disease has a certain degree of immunity for a while. And it became obvious there was an absolutely classic case study to work on, because of what you had in there. And if you look at what happened, in fact, we planted, in fact, cholera in this place. It was UN peacekeeping troops United Nations sent out against the looting and the robberies of the houses, etc. And there are a few of those, soldiers, in fact, there was asymptomatic, in fact, carriers of the disease. They started shedding. There was no protection whatsoever, and we planted it in there. And what you're seeing here, what you have seen, in fact, developing here, was the stupidest possible statistical count, which was available worldwide immediately. That is the number of confirmed, quote unquote, confirmed but reasonably attributable cholera cases per day, which were published normally by the PAHO, the Pan American Health Organization, in there. And you see what happened after 6 months before it blows away. And what you see in there is a number of cases. Yeah, what I was showing you, I'll show you the rivers again. What happened is that the mechanism for transport of a pathogen was inevitably the waterways that act as the water supply for the system. That's why it became the rate of infection and the rate of death for other reason was majestic in that case. So long story short, there are two major contributions in this area, the two masters of the field. One is Ilka, the late Ilka Hansky, and the other is Marino Gatto. Because in that case, we soon realized that, in fact, exact results apply to the epidemiological case in a spatially explicit manner. That is, if you place a settlement, human settlements where they are, and you collect by networks, which are river networks transporting pathogens, and human networks, that's a multiplex character we've seen in biological invasions, like in the case of a zebra mussel. So essentially, you immediately realize that there is a system in which what is, in jargon, from a system, say, of coupled ordinary differential equations for characterizing what happens in one system, but you can link all of them by networks, physical or mobility networks that you have in the system. And this could be solved exactly, in fact. So you can study exactly the stability of a disease-free equilibrium, or in the metapopulation model of Ilka Hansky, you can study the probability of survival of a species in a given environment. Compellingly, precisely, over large scales, which is a Copernican change in the way we can attribute a value to the natural capital in this case. And if you look at what happens, well, just to show you an example of how we proceed, data on one side, reconstructed cases on the other. And the point is that why can we then put a price tag on the environment? Because we can calculate exactly how many cases you're going to have, exactly, with a very reasonable approximation and with a certain degree of robustness. What happens in this case of a life-threatening condition, but could be done for, in fact, for a poverty-reinforcing disease. For instance, in the case in which in Burkina Faso, you had 15,000 small dams generated when the World Bank started stopping financing the high dams, we have shown their limits and the problems that they generate in the system. Well, what happens in this case is that, of course, in the GDP of Burkina Faso, you immediately saw the advantage given to agriculture to improved irrigation in that case. But you never put the price tag of a debilitating disease that spread bilharziose or schistosomiasis over unheard of territories. So the idea is that that's what we mean by distributive justice in a sense. And this is the last slide I'm going to show you, because it's quite interesting, because it also talks about the fair distribution of water. What happens is that in the poorest country in the world, but in the entire south of the world in which you have done work, that be it Bangladesh, be it sub-Saharan Africa, be it Haiti, whatever you want it, etc. Access to safe water, it's biased, socially biased. Not the ownership of a cell phone, however. What I can tell you here, it's a blurred picture, because in that case, we were taken by Terre des Hommes, which is an NGO based in Lausanne, France, that they would take you around with those armed, in fact, cars. Because don't open the window and take a picture. They can kill you just simply to steal your camera. So it's blurred, the picture that you see in this case. But what I saw with my eyes, at the peak, at the height of a deadly infection that you had in the poorest country in the world, here, I was there, I can tell you the date of that, this lady with a red dress, in fact, in a second, in fact, stepped down, took out from her hand a Nokia 900, because I did, and showed with an app, a proof of payment to the lady selling cabbages in this place. And I saw it with my eyes. So I saw the transaction, I got the cabbage and ran away. So there's something funny about a society which cares for the infrastructure that allows the cell phone to be uniformly distributed to the point that is not considerable a socially biased ownership of one of the cell phone, but you don't have a water distribution system, in fact. You don't have any of the sort in there. And in reality, so again, who put the technology there? It's us, it's the north of the world. If you're talking about the mitigation possible, it means that you have to tell people pontificating about what they should do when their welfare is relatively better after what we have done to our resources and to their resources as well. So that's the reason why, in fact, I came to believe that it's not going to be possible for a system of this kind to propose, in fact, a meaningful, in fact, transition to a mitigation process. So, and I'm going to my conclusion of this other following. When I received the Stockholm Water Prize, in fact, the first thing that in fact, without undue solemnity, as Russell would say, they told me, like, look, this puts you a megaphone in your hands that the world will listen. What would be your message? And the message, what I say, and I really believe, and I repeat it here in my conclusions, is that time is ripe to rethink distributing justice in water resources. And that means as a tool for the general reduction of inequalities, based on the fact that not in general, but in particular in the water field, now we have tools to be able to put a price tag of ecosystem services. So we can actually access the new economy that looks at the integrated view, in fact, of the role of humans that do not simply draw on nature like Simon and Partha Dasgupta are advocating. I truly believe this is the case. And we have the tools, and I really think that the time is now. Now, because as we said, climate is rapidly changing, and so should we. Thank you so much.
We can sit down. Thank you so much again, Andrea, for the wonderful lectures in the first place, but also for agreeing to come here and to provide so much food for thought. Does it work? Can you hear? So you have raised a number of very, very important questions, from water distribution to biological processes to a number of challenges that modern our modern world is facing. Now, I am a historian. I can tell you that if the future is not what it used to be, also the past is not what it used to be. The past has been transformed by the sciences of the past, by paleoclimatology, the paleosciences, and that has allowed some historians to become more aware, shall we say, of natural processes, of natural systems, of the interactions between human systems and social systems and natural systems. And this is creating a new, I mean, we are stepping into a new order of historical questions, let's say, which can only be answered by more interactions, more understanding between scientists and social scientists and humanists in general. But how to do that? And that is our basic questions. And tomorrow, by the way, we are going to explore these questions in a workshop, which will take place here at the Institute in the West Building lecture room, about 100 meters past Food Hall. You're all welcome to join us, of course. We will have several speakers from different disciplines: history, climatology, and archaeology. But this is part of the conversation. How can we make sure that our different training and knowledge systems and so on can interact for not just to find answers, but also to produce more interesting questions. A number of people say, well, human beings have always faced droughts and floods and so forth. But we don't really understand very well how societies responded to these natural events. And now we are starting to get a better appreciation of the nature that surrounds these events. It could be war, migrations, the collapse of civilizations, and so forth. But we need to establish some structures that allow us to interact, and not just in the short term, also in the long term, to make a real investment in joining our different spheres of knowledge. Your work has been very, very inspiring, and but we cannot but be grateful to you for the efforts that you have made also in terms of combining your knowledge with social knowledge, economic knowledge, biology, and many other different sciences. So do you think, this is my question, do you think we are prepared to move into a future in which science and human sciences and social science can get together to answer these fundamental questions?
Well, first of all, let me, well, you know that, but I'm pleased to report, to state up front how much I admire the work that you've been doing and your group has been doing in finding out this connection between the physical sciences, biological sciences, the way we see it, the hard, true science. I mean, with, for instance, Nicola gave a talk, however brief, but totally revealing about the societies without history, in which essentially what you have about societies that do not have records of what happened. Then you can go back to DNA studies, in fact, to tracing of genomes and climatic records for fitting the things. And this is a complete change, and there is no doubt that this is the future. Now, you were talking about the cities in which you have an idea on where springs could have been and how they supply water. Then we don't predict. We make scenarios. What if? If I looked at the Nineveh irrigation, the BIS, they call it in Switzerland, system which have been developed in completely different cultures, thousands of years of different setup, but inspired by something which is necessity in a sense. And then we know what could have happened. We can simulate, we can interpret what happened. But the idea of this consilience, like Ed Wilson would have said, of something in which you need to know history and the tools of history, the fonts, in fact, the sources of history, but legitimately you have to have an information that comes from the sciences. In fact, could be an element, not the only one. Like again, and something which we have discussed. It's Bertrand Russell, of course. You cannot say the causative factor, the history of history is hydrography. It's one of the factors. There are many of them, the multi-interacting things, etc. And you have in the different areas, and the things that you can federate, you can join them. We are at the verge of a new discipline. And what I loved about this, Paul Vidal, it was that he said, our future and the letters. Well, this is the guy who coined the future is not what it used to be. He was a philosopher and a poet. And letters means in French is the humanities, in fact. Our future and the humanities are related, in fact, and that's the way it should. So I salute and I'm totally enthusiastic about the work that you're putting together. I only wish I were younger to restart, to reset and work in that area.
Don't we all? We are very happy to take questions. I'm sure Andrea is happy to take questions now for a few minutes, if you have any. Okay, here.
I was surprised that you didn't comment on also some of the criticism it got from the environmental community, which I was also a bit astonished by the level of criticism. A lot of the environmental groups felt that by elevating this price tag approach to nature, that you were commodifying it to the point where if the numbers didn't come,
We can use the.
but I'm just wondering how you feel about it. And people have said that about, pricing water as well. So how might you try to respond to that kind of criticism?
Well, you probably can, they probably haven't heard.
Okay, I can repeat it, sorry. Yes, so the question was that the Dasgupta review, which is, you referred to the academic version of the paper, but this was a British government commissioned report on the value of biodiversity. It was criticized a lot by environmentalists when it came out, because there was a feeling that you're commodifying nature in a way where it could then later be misused. And how might you respond to that criticism?
I side with Partha Dasgupta 100%, without a doubt, and with Simon Levine, in fact. The idea that you can look at humanity is not embedded in the thing, it's an error, essentially. And I think I side with them completely. And environmentalist, it's okay, let's define environmentalist, because I feel I am one. And so, but in a sense, I'm totally 100% on that side. The Dasgupta report is a milestone, in fact, in that direction. The idea is that, you see, I don't want to trivialize it too much, but when you say that something, it's something, it's priceless, right? You intend to mean that it's precious, etc. Priceless means there's no economic value. If you don't put a price tag, however unclassy it might look like, it's absolutely necessary. And we're starting inching towards giving a quantitative evaluation to ecosystem services, evaluation of a natural capital. The idea that no economy can thrive by mining natural capital. The wealth and the poverty of nations cannot ignore the natural capital as part of that. And whatever little space you have, and in this case, it was a particular case, because in other cases, I started saying that, for instance, in the case of even simple questions, that if a young guy drinking a glass of water from the Magna River catches cholera, the odds of it's just you don't know, essentially. The uncertainty is fraught with uncertainty. But at least you isolated the cases where the variance, that is the error that you make, is very much reduced. And then in this case, it's the universality of form that transports to the universality of function. And that's why, in fact, but it's of course, a river network, of course, if one cures a certain disease, you see the disease everywhere. But I'm telling you, the river basin is not the entire set of ecosystems, but it's a large chunk of them. Large part of biodiversity rests in the river basins of this world, in fact. So that's something we really care about. Anyways, I'm 100% Dasgupta Levine guy.
So just thinking about the sort of unequal distribution of water on the planet right now for human use, so limiting it to human
In
use.
space and time.
And space and time. How much of that is related to uneven so you can contrast water with a cell phone, in that in order for me to use a cell phone, other than getting electricity and the infrastructure to use it, I only have to buy the cell phone once. But in order for me to use water, I have to get, I don't know if the 700 liters a day is really necessary, but a few dozen liters a day, right? And that's a lot of mass to move every day. How much of the lack of distribution of equal distribution of water per person is associated with sort of a natural supply of water relative to our inability to maintain that water in a usable form, either by keeping it from having disease in it, or having chemicals in it, or just being able to harness it? So how much of it is in the natural supply versus our ability to harness it usefully?
Okay, that's interesting. That's an interesting question. What I'm saying is that it's a matter of priorities, in fact. When Gaddafi was approached about the fact that in this big tunnel he made to tap fossil waters under the Atlas, he was asked, "Sir, but this is not sustainable." I was telling this yesterday, and Gaddafi said to the interviewer, "What do you mean, soil sustainable? That water has been charged there 30,000 years ago. It has never been recharged, etc. Once you've taken it out, you pulled it out, and for good. So, but sir, you just run out of water. No. Said, Inshallah, God put it there. We use it. If God wants, He puts it back. And these are the examples of so-called invisible structures. That is the tradition of the places, the sensibilities that the people have, the political organization. This cannot be bypassed. But in reality, you have to get into a thing what a German, in fact, say ecologist I would call Friedrich Ratzel in the 19th century called the Lebensraum, the vital space that you have. That is one in which you look at the landscape nature integrated by the work of man, which is part of that. So in reality, back to the question, which I just took it from a large side. The fact is that, first of all, there's no work or thing that fits all situations. You have to face invisible structures, the traditional places, the changing context, however. The point is that you have to, and we failed miserably so far, we hydrologists, we failed so far to convey the idea that the rapidity of the acceleration is in reality generating heterogeneous patterns. I was showing, but I didn't, it was when I was losing sheets, I couldn't find my notes any longer. When I showed that picture of the drought in Italy in 2022, 2023, in fact, what you see that large parts of the country was completely, I mean, super arid. And the southern Italy, which is normally the arid part, was completely wet. These patterns are completely shifted, in fact. And in reality, what you have is that the corollary, first of all, floods and droughts are two faces of the same medal, the warming, the fever of the planet. They are related. You can show that conceptually they are two faces of the same coin, in fact. They come together. And this heterogeneity of past, and in reality is the same reason why you see, if you look from faraway place, certain places in Sahel, in sub-Saharan Africa, you see traces of teeming rivers that flowing in this place, even in a place in which the driest place on earth, in which you haven't got a drop of water in 38 years. That's what it happens now. So good fortunes don't last forever. And again, if you want to quote the poets, Shelley, you remember Ozymandias, he was showing the set of ruins scattered in the desert. And I think I'm quoting it, it should be somewhere in there. He will say that I'm Ozymandias, king of kings. Look at my power, ye mighty, and despair. And was ruins scattered in the sand, in fact. This is the point. So you have to figure out that the system in which we advertise the fact that the corollary of what we're seeing now, the rapidity of a cycle, means a very dangerous thing in which shifts can happen very rapidly. The example I was showing, I don't know if I gave the right emphasis on that, within 2 weeks, you moved on from a serious drought to a disastrous flood in the same places in Italy. And that's the sign of that. It's the rapidity of the cycles, rapidity of the changes that you have. What would have taken 1 million years to happen, happened in 100 years. Consequences are major for physical laws that you have. Talk about all the scientists you deal with, meteorologists and whatever, all kind of things, etc. The extremes are more extreme. And in a sense, if I want, the future is not what it used to be, it's a good occasion to quote Stephen Jay Gould talking about sports in a beautiful book called Full House, in which he was looking at biological evolution seen through the statistical baseball, in fact, and the disappearance of a 0.4 batting average. If you haven't read that book, you should. It's a masterpiece. It's the full house, means that you have to study the entire distribution, what happens in the system in which even the batting average, the average batting averages in the statistics of a baseball has not changed. And yet nobody would be able to hit the 0.4 batting average any longer. Why? Because everybody else improved. And so the system, you have to look at the full house, but the entire distribution, how the variance of the ability of a professional baseballers, in fact, showed the process in there. And that's why the future is not what it used to be. We're looking at something in which we can only partially predict what happens, but in reality, it's the uncertainty that happens, the scattered patterns in space and time that prevent a single measure to be the solution to the problems that you have. And back to the problem that interests Nicola, in fact, what I found absolutely fascinating is the idea that What was missing in what we do is the historian's view. The idea that patches it all together in what happened in history, because the records, the geophysical records, the biogeological indicators are only a part of the equation. It's only when you get the context that includes man fully that we'll be able to understand really what we happen. So we are at the verge of a really fantastic new discipline being born. I can bet a beer if you want.
Thank you, Andrea. I must say, very impressed with how conversant you are with baseball. Yeah, for an Italian. Sorry. Jörg, and then Julia.
Thanks very much, Andrea, for this very inspiring talk. I wanted to ask you specifically on the SDGs, whether we have Sustainable Development Goals 17 and one, number 6 is especially devoted to water. And it says, ensure availability and sustainable management of water and sanitation for all. And these SDGs should be achieved by 2030. So we have just a few years to go and achieve these SDGs. And according to Antonio Guterres, Secretary General of the UN, in his report last year, he said, we are not on track. There's about 15% achieved of these SDGs. So I just wanted to ask you, what are your ideas? What needs to be done to actually achieve SDG 6 on water availability, sustainability?
It's beyond me, Jürgen. And what I'm saying that we are not on track, it's completely, I completely agree on that. In reality, it's several patches. I think what is missing is that some unifying description is a grammar, something. A grammar is a good term that was used for these, the new economics, including man. There should be a grammar that is a common language and a common set of rules to interpret what's happening. It's not the case. It is not the case. And in reality, what you have to realize that, again, there can't be a single measure, I was saying before. There can't be one. There can't be a solution that fits all, a measure that fits all solutions. And the context is very important. Look, for instance, in Italy, the big debate about fair distribution of water. What I keep telling, and it was a major mess happening where they said, look, to me, what I said that in one of those stupid interviews that they air maybe in some obscure news in deep night and somebody catches it up. But what I said is that we have obviously to rethink agriculture. We have obviously to rethink irrigation system that you have, because you have to rethink privileges established since, since a long time. And of course, every privilege, every institution which is privileged is conservative, but you have to rethink all of them. And that enough to get then interrogations to the Senate, etc. But because that's exactly what it is. We really don't have a clear roadmap, Jürgen. I'm pretty sure of that. And you can open up to the system, but it's not the first problem of that kind that failed miserably. In fact, quite a few of them did in the past.
Andrea, thank you very much for your talk. I'm Julia Thomas. I'm from the University of Notre Dame. I want to follow up on the first question that was asked about assigning prices to nature, ecosystem service prices. And I have there have been three critiques that have been made of this idea. And I would like it very much if you would talk a bit more about these critiques and how you might respond. The first is that we simply don't know enough about the natural world yet to apply prices. We have an estimate of how many species there are, but we don't know for sure. So how do we begin to put price tags on species? The second one that you've alluded to in your talk is the fact that we are entering a new state of the Earth system where there are thresholds and tipping points, so that we don't know how things are going to develop anymore. We've moved away from linearity to a much less predictable system, which also makes it difficult to price things. And then the third element of this is the human element that Nicola and I study, which is we don't even understand the way people value things in different cultures all around the world, which they always do differently today, let alone what they will think is valuable in the future. And so that too would need to be factored into these pricing systems. So those are the three critiques of this idea, and I'd love to hear a bit more about your response to them.
I'll start with the third because it's the easiest one. And the third is that when I was talking about the invisible structures, it's a term coined by a geographer. I was talking about precisely that, because it's not that you can attribute the same value everywhere. The tradition of the places, the political and social organizations that matter a hell of a lot in defining what can be done and what cannot be done in that sense. So it was a way of say, setting it aside, not because it's not important, but because it's absolutely necessary. In terms of the other two, what I can tell, I don't want to claim too much, but what I'm saying is that pricing the planet is necessary. However bad this sounds, meaning you have to have a system through which you can actually compare reasonably on equal footing. You have to put into the indicators of wealth, you have to make sure that you have to take into account the natural capital somewhat. And this is a start. It's not the end of it, of course, but you're just starting in one particular case in which you are, in fact, aided by the fact that the form of the substrate for those ecological interactions is always the same in nature. There are not very many that do like that. At the beginning, I was talking about the guy drinking the water, because that's a case in which we will never be able to put a price tag on that. Because in that case, theoretically, that the uncertainty you're going to have on predicting the concentration or something of that kind in one point in space at that particular instance of time will never be able to achieve that. Theoretically, it's unreachable. So it's not that you can do anything, etc., but you can inch towards something in which you're trying to do slightly better. And in terms of the values of different species, etc., it sounds bad, but in reality, what you have is that you have to take into account how immaterial quantities become part of the equation, because they are not now. The fact, I was making the example, maybe naive, but for instance, Burkina Faso claimed that it was a fantastic result of the 15,000 small dams through which the GDP boomed up in there. But you never put the price tag in there of a disease, of a poverty reinforcing disease that expanded enormously within the territory. Why? Because you cannot predict it. And now you can. Now you can do that. In retrospect, you'll be able to realize how much by enlarging the habitat for the intermediate host of a disease, which you can, if you can destroy it, you can interrupt the cycle, in fact. You understand now how this happens. There's a lot that we know now that can be used. So what I was saying is that it's not time is ripe for solving the problems of the world. No, but time is ripe for rethinking many things. The little things in which we got a specific knowledge. And in that case, especially if water is involved, we know quite a bit. There's no excuse for not using it. That's my take.
Hello. So I'm a theoretical chemist, actually, at New York University, but I enjoyed, the aspects of the models, basically. Like for instance, modeling how will the sea levels rise as a function, over the next 100 years or so. The problem is they're all very smooth curves, assuming that all the variables change smoothly, actually, in some sense. But the problem is that, especially the sea levels, actually, will be most dramatically impacted by changes that we cannot actually predict with any certainty, like, for instance, melting of Arctic ice or Greenland or things like that, which in turn will shut down the current patterns in the oceans and lead to. So we are dealing with essentially an incredibly highly nonlinear phenomenon. We just hope that somehow we will stay in the linear regime. So what do we do there? I mean, that most drastic changes can happen precisely because of things we are least able to predict. And a second comment is that it seems to me that at this point we are much less limited in our ability to act on things by our scientific understanding, but our political will to act. Actually. I mean, we know that we are depleting the Ogallala aquifer like there is no tomorrow. We are planting the most thirsty plants in the driest parts of the United States and everywhere else. We know all that. But we are greedy. We are unwilling to actually take action. So that's okay.
Question, I may take a sideways look at that. Dickens used to say that no intellectual has been optimistic in his own time. And we're still hanging on. Let me take a few good examples. In fact, if you look at those diagrams, for instance, it's a theoretical chemistry problem. But so one of the few issues in which the hockey stick diagram is interrupted is the stratospheric ozone concentration. That Crutzen and Mario Molina and etc. It was exactly a small piece of understanding. It's the only curve which was going up, and the only one that flattens out. IPCC, I'm a good friend of Thomas Stocker, who used to be the responsible for the science of the IPCC. He's a professor of climatology in Bern. He's a student of Osher, one of the masters of the field, etc. And what I can say that the approach, of course, is not perfect. Of course, it's strongly nonlinear. Of course, there's a hell of a lot that we don't know. But in reality, what you're seeing is the strive to converge into something has been useful, because if you look at the error bars that you have in predictions and what they do, in fact, it's a very neutral approach, if you want. So you take an ensemble of models of different guys, I said, you run them all together and you study the ensemble trajectories generated by those models. And from there, you start inching towards a likely distribution, not perfect, certainly, but certainly strongly nonlinear, because the climatological models that we have nowadays are very sophisticated piece of work. And meteorological models are interesting ones, etc. There's a hell of a lot we don't know. There's a hell of a lot we should be doing better in measuring. For instance, a great faith was placed on these remote measures, like with a radar, for meteorological radars, for evaluating the simple things of the distribution of rainfall. When you say that in Italy there's an expression, there's la distribuzione a pioggia. There's a rain-like distribution of money. There's nothing as unrain-like like a distribution of water in the territory. We cannot really characterize precisely the distribution of how the good Lord sends the rainfall in space and time. There's a hell of a lot. But the idea behind that, what the Crutzen and Molina thing, I don't remember the name of the third guy that got the prize for that, showed that at a certain point you can have a synergy focusing down on a certain problem and solving it. We have shown it. Now, the idea and the reduction which is behind the IPCC, I think it cannot be, if you have to reduce matters. There's not a single historic cause. There are multiple hydraulic causes, but you try to isolate one. Hydrography is the main determinant of history. It's not true. It's pleasing, but it's not true, because there's lots of things. Like in this case, you have to figure out how to reduce the temperature of the atmosphere.
Averaging has always failed to predict precisely what matters most, crisis, because they are not in the models. You extract, all these returns on markets and so on, and they all assume nice, smooth variations until a crisis hits, and then the models all go wrong. That's the point. The models are unable to predict upheavals.
There are pieces of mathematics, in fact, that address, in fact, the catastrophes that can be generated. And in reality, what I'm saying is that what I appreciate is the effort, is the sense of direction. Theory of models are telling you much more than when they started out. For instance, we know, for instance, if you over-parameterize a system, whether it's bullshit, but you get it, or whether there's some meaning into that, you can measure that. You can use Bayesian statistics to make sure that the outcome that you have, whether it has a meaning or not, there's a lot of say, checks and balances now in place. It's far from perfect, of course, but I love a sense of direction. I love a sense of direction. I love the sense that in reality, that's the direction in which you have, and the very idea which is behind the IPCC is very healthy, I think. Highly imperfect, but very healthy. And I'm hopeful, in fact. As I was saying, in fact, in the case, for instance, I'm worried about my city. Why? Because I said the IPCC most likely scenario says a meter. If you get these tipping points occurring in Greenland, it could be 7 meters. 7 times as much. So whatever you think of possible solutions would be dead, gone, and perfectly useless in there. So I agree with you in a sense, but I would like to leave a sense of hope, a sense of direction again, which I'm faithful on. I hope we can, I don't know if you share it, but certainly I'm happy of that.
I'm sorry, my question may not leave us with hope, but nevertheless, I'd like to ask you about what appears, or at least in my mind, is sort of an elephant in the room, or given the watery theme, maybe a whale, but that is the question of population size. Much of what you showed, I think, is really compelling, and following these models and the way in which there's sort of synergy, or let's say convergence between natural systems, human systems, and historical systems. As an archaeologist, to me, one of the biggest differentiations between the modern scenario and the past is a simple factor of population size. To the question, how in your formulation of how water is distributed and as a force for transmission, if you adjust population size, in other words, if you parameterize population scale, how does this affect the model? In other words, what changes if we go, if we unrealistically say, go back to a population of 400 years ago or something?
Okay, now, demographers are pretty learned, in fact, modelers actually. So you can actually even invert the arrow of time and go back in time and figure out what could be distributed. Well, I'm not claiming we know everything, of course, we're far from it. Our knowledge, but what I'm saying in a sense is that the quality of what we do is way more relying on the quality of the questions we ask and the answers that we contrive, imperfect as they always are. But the idea is that, well, for instance, yes, if you get a good picture of demography in time, in deep time, that'd be fantastic. Of course, you have ideas, you have no proof. But even in societies without history, you're starting finding out a way of finding out some objective evidence of that. And what I'm saying is that, in fact, well, in that case, what for us it meant is that when you get a unity of computational, say, theoretical tools of wet lab experiments and field work, and you get the same thing at different scales, then you start having a suspicion that probably there's something in this, actually. Because you do experiments, you do field work, you do theory, and you put them together. What we mean, we're still missing the historian that puts this in the perspective of what has happened. Whereas typically, in this case, you're looking at what happens from what you have now, you project it, and you make scenarios in time. But so essentially, I don't know how to answer that. But certainly, I mean, you can mobilize theory by demographers, which is super sophisticated. And I'm pretty sure that you can have like Cavalli Sforza and Hammerman did like 30 years ago. They started looking at archaeological traces from a passage, and they calculated the speed of the traveling wave in Neolithic transition, which matches evidence that you have a certain dating of different settlements that you have along the path of the dispersal. Is it perfect? No, because you realize other things later on. But it's the first way, and that's how science proceeds, actually. And I think this consilient look, which in the end goes in your direction. We need the archaeologists, we need the historians, we need the DNA guys. For instance, there's a tool called environmental DNA, which I mean, we used it actually in some cases. For instance, you just get a slug of water, and what you can see on that is whatever you can realize, whatever species you have in a sense that shed those little strands of DNA that get lost in the thing, etc. But then you need a theoretician, because the fact that you were there when you picked it up, it doesn't mean that you know where it started out from or where it started out from. Sure, you can do something. And then at a certain point, uncertainty becomes major, so you lose sight. But at least you know, you can measure it. Uncertainty can be measured. You know when you go back in time for in the inverse problem, so-called this famous Kolmogorov guy who was a genius of the last century, a mathematician, he's telling you in the inverse problems, you have limits in what you can achieve, at least for what we know now. So there's serious science behind, and there's serious social impact in that. I'm pretty sure of that. So I think that I don't have a preoccupation that new generations can have, in fact, a very, very interesting field to exercise. In fact, I think at least I'd like to be at the end of my career, but yes, but I think it's a very exciting time to be in this business.
And we will continue this conversation tomorrow at 9 in the morning at this public workshop, which will continue to deepen our understanding or our effort to, in fact, understand each other as we compare notes between scientists and archaeologists and historians, in the hope that we might be able to perceive in a better way the interaction between natural system, human system, not just for the present, the future, but also in the past. So let's thank Andrea again for this wonderful lecture.